All right, good afternoon, everyone. Thank you for being here. Hopefully the next hour will be worth your time and you'll get a few things out of this talk, and we'll discuss a few topics of interest for all of us and where the industry is, where the industry is going, the kind of work that I do, and the kind of work that the industry is moving towards. So let's move forward and making sure that I take good on time. All right, so my name is Bushra Anjum. I am originally from Pakistan. So from Pakistan, I did my undergraduate and master's both. Then I got Fulbright scholarship and I came to the United States for Ph.D. I graduated in 2012. And after that, I was serving in academia for the next 3 years. So I taught at NC State University as an assistant professor, then at Missouri State University as an assistant professor. And then seeking for the next adventure, I switched to industry. Worked for Amazon for about 4 years in San Luis Obispo. I was part of their Prime team, and our team was very engaged in international expansion those days. So we introduced Prime to India, to China, to Mexico. Those were interesting times. And then just about a year ago, I switched from Amazon to a startup called Doximity. It's right here in San Francisco, south of Market area. And I joined them as a senior member of their data science team. And about 6 months ago, I switched to a managerial position. So currently, I am their data analytics program manager. While I still have like 30 to 40% of my time that I do individual contributions, but the bulk of my job is now looking after other engineers and senior data folks in our company. Talking briefly about Doximity, because I will be sharing a couple of examples of models and a few other things from our day-to-day work. So Doximity is a combination of 2 words, doctors and proximity. So one of our initial investors suggested it and it kind of stuck. So it is a networking site. I'm not using the word social because doctors are not very social. It's a networking site. You can say that it's kind of like a LinkedIn or a Facebook, but only for medical professionals. So it's a closed networks. And only doctors and nurses and physician assistants who have the NPI number can sign up to that network. And because it's closed, it's HIPAA compliant, and that gives us a few options to provide some services. So for example, if two different doctors want to discuss a particular patient and they want to make a referral, they can discuss about that patient using Doximity. Doctors cannot talk about their patients using text or email. It's outside the HIPAA laws. But because this network is closed, so all those kind of collaborations and referrals are possible. And then, of course, there is the other options of the network that you connect with your colleagues and you connect with people you went to school with or residency with. And then a few other facilities such as the option of online fax. So you can have a document on your phone, you can sign it there, and you can send it via secure fax. So from your phone to an actual machine. You'll be surprised how much data and information is still passed on in our hospital systems using faxes. So that was one feature which was very widely picked up and supported. The other thing is that a lot of doctors and nurses make after-hour phone calls to their patients, like for follow-ups, that how are you doing? Is the procedure went okay? Do you need any additional help? And most of them have to do that from their medical facility. They cannot do it from their phone because otherwise their patients will have their personal phones. But using Doximity, we provide a service called Dialer, which kind of masks your personal phone number to the facility phone number at where you work. So you can still call your patients at the comfort of your home from your phone, but as far as the patient is concerned, they will see the number of the facility. So it gives doctors a little more flexibility that they don't have to stay late to make those calls. A few other things, I talked about electronic faxes, patient treatment, Dialer. Then Residency Navigator is something we started for 4th-year medical students, that there is no comprehensive database that tells them which residency institutions are there and any kind of ranking, which one is better, which one is not. So because we have so many doctors on our network, which is now 70% of US doctors and 45% of nurse practitioners and physician assistants, because we have all those people on the network, using their input, we provide the 4th-year medical students a Residency Navigator. That what are the institutions, where are the openings, and what are their different ratings, what are people talking about those institutes, things like that. So now because we have so many users on our network and we have more members on our network than the American Medical Association. So that gives us a strength to create more products for doctors, nurses, and eventually expand out into the healthcare system. So exciting times for us. I work in their data department, so you might wonder that what do we do in the data department? Well, anything that you can imagine being done in a Facebook or a LinkedIn, that primarily all comes to that. That you want to recommend better connections, that you want to connect with colleagues so-and-so. Then of course our revenue generation model is ads. So better placement of ads, then tracking the activity on ads, then also making recommendations that if a doctor wants to refer his or her patient to a very niche subspecialty, we kind of try to do that matchmaking and make suggestions that why don't you talk to this doctor or that doctor. So that recommendation comes into place. And then of course we track all the engagement that happens on their system. We have 3 platforms that we support right now, web, iOS, and Android, and all of them have their individual tracking capabilities and challenges. Didn't I have, this is I wanted to talk about first. So this is our data ecosystem. Some of the tools are homegrown that we have developed ourselves, but many of them are third-party vendors. So for example, let's talk about a few. Segment is our event tracking service that we use. So they send us all the information about the user activity on the app, whether it's iOS, Android, or web. Snowflake is our data warehouse. It's a cloud-based data lake service provider. Then, of course, we use a lot of Amazon Web Services. Amazon Aurora or MySQL is our production databases. Then we use Airflow for a lot of our workflows and making sure that they run on specific times and in specific cycles. And then Kafka is used at a number of different places as distributed queues. Docker containers, we use them for deployment. GitHub, CircleCI, the regular stuff that a lot of people use. So in general, the few main things that I will be talking about later also is Snowflake, our data warehouse, Amazon Aurora, which is our production database, Segment, which sends us all the tracking information, and Looker, that's our visualization engine. So we create our dashboards and our graphs via Looker. So first thing that I want to talk about today is dimensional modeling. So you may have heard this term, you may have not heard this term, so let's start by assuming that you haven't. So dimensional modeling is a data modeling technique, a database design technique. Most of us are familiar with an alternate database design technique, which is called relational model, or 3NF, where we try to normalize the data as much as we can so that we can avoid duplication of data and duplication of rows. So 3NF form, or relational database, or transactional database, I'll use those 3 terms interchangeably. Dimensional modeling design is slightly different. It has a different goal. Whereas the relational databases are for real-time systems, dimensional model-based systems are for analysts and data scientists and business and other business folks that might want to keep track of how things are going in their particular business. So their audience is different. One is the real-time transactional system, that is 3NF, and the other one is for analysis, scientists, business users, and that is created by a dimensional model. How are they different? We will also get into that, but first let's try to solidify that concept a little bit more. Transactional relational model, or the 3NF model, versus dimensional model. So as we briefly said, relational model is normalized. We try to avoid duplication as much as possible. The dimensional model is denormalized. We try to bring together related concepts as much as possible. There will be duplication, but that's okay. So for example, if we are talking about 3NF or normalized relational model, we may have a product table or a product entity, and then we may have a category. For example, it's like household cleaners would be a category, and then maybe a specific company would be another entity, and then the actual product specifications may be another entity. So product specification could be like 13 ounces bottle, and then the exact company could be any major brand, and then the category would be household cleaners. We would like to keep them as separate entities in the 3NF model to avoid duplication. In dimensional model, we want to group all of them together in a single table, which means that for each of the product entity, there will be duplication in terms of the name of the company, and there will be duplication in terms of which product category it belongs to. But it's okay because we are trying to keep related data together in a single entity. Why does it matter? Let's hold off to that question for a few minutes. The other thing in relational model is that we want to reflect the most current state. So for example, consider an employee entity. If their salary changes, most probably the salary data would get updated to reflect the latest number. However, for dimensional modeling, because we use it for analysis, we want to maintain the history so that we can go back and see how different things and different variables are performing over time. So whereas relational model reflects the most current state, dimensional model keeps historical context as much as it can. So we talked that transactional relational model is for the real-time systems. So the focus is the quick real-time read and write access. Whereas the focus of dimensional models is different. There the focus is on fast search and fast retrieval of large amounts of data. So completely different functionality, reads and writes of transactions versus search and retrieval of large amounts of data. Talking about large amounts, transactional models, their reads and writes usually deal with kilobytes to megabytes data. It's only a handful of transactions that get read or written at a time. Whereas for dimensional model, the scale of the data that we deal with is gigabytes, petabytes, terabytes. Data consumers are online transaction processing systems or software engineers which are designing them, whereas the consumers for dimensional models are analysts, scientists, business folks. So it's a wide array of technical background, you may say. Whereas those dealing with relational models are usually very, very technical people, or the system that they developed. The people who are using dimensional model related data have a vast array of experiences. They could be your product managers, they could be the commercial people, they could be analysts, they could be data scientists, they could be software engineers also. But we have to keep that in mind that this model is something which focuses on usability and user understanding. That's why the earlier point of bringing back related concepts in a single entity, that rather than people having to look at 3 different tables to figure out what a product actually is, all that related data is in a single table. And last, if you have to remember just one thing, the main difference between relational model and dimensional model, it will be that the core directive of a relational model is to protect the transactional integrity, the asset guarantees. Whereas the core directive of a dimensional model is to be simple because it's being used by a wide variety of people with different technical expertise, and it has to be fast because you're trying to deal with gigabytes and terabytes and petabytes of data to get some actionable insights. So having this brief background or introduction in mind, what does dimensional design really look like? We kind of know how the 3NF form works. We have some formulas and we try to break tables into individual entities. For dimensional model, the process is slightly different, and I'll briefly go over that. First thing is that we try to identify a business process. So business process is really an application area, a verb that your business is doing. So for example, sale is a verb, purchase is a verb, maintaining inventory is a verb, user engagement is a verb. So any actionable, physically actionable item, data or events that are happening kind of make a business process. First, you have identified a business process, that what do you want your users to actually dig into and find insights from. Then you've defined the grain. So grain basically means that at the lowest level, what data would be available. That's where a lot of buy statements come in. So for example, let's talk about sale, that a business process of sale, we want to build a dimensional model around that so that people can get insights from how sales are doing, how they're historically doing, which things are getting better traction, which are not. So we have a sale, and then we want to figure out how do we want to actually analyze this sale. So one item could be sale by customers. So we want to have data for each customer for the sale. All right, what else? Well, sale by customer by product. Then not only we need information on each customer, we also need information on each product. Okay, what else? Sale by customer, by product, by date or time. And by date or time, I mean that it could be consolidated or aggregated over days, over weeks, over quarters, whatever time frame you want to discuss. and then so on and so forth. So every time you add a by, we want to analyze X by A, by B, by C. Those A, B, C entities become dimensions. So those are the things with which you want to analyze the data. And the exact data that you want to analyze, that become the facts. So in dimensional model, these two words are used quite a bit, facts and dimensions. So facts are measurements from your business process. They are usually numeric, like sale price or other things, in number of items and how many days a particular transaction is taking, usually numeric values that you are interested in. How many users are logging into your website, how many users are using product X. So usually numeric, though they can be non-numeric also. And then this data, on which dimensions or how you want to actually analyze that data or aggregate that data, that becomes each of the individual dimension tables. You may have heard there is a term called 5 Ws in reporting. So whenever you want to report an event, you want to cover the what, when, where. Two more. Any ideas what they were? Who, what, when, where, who, why. So these 5. So basically the dimensions become these 5 Ws. And then the facts are the actual data that you want to analyze. How does that look like? So this is an example from our database system, slightly simplified for this example. So we want to basically track user engagement. And we want to track user engagement by users, by products, by platforms, by specialty, and by dates. So all the things that we want to track these or explore these by, they became the dimensions. And the actual data that we want to analyze within this context become our facts. So you can see the fact table, which is in the middle. It has IDs from all these different dimensions. And then it has a few attributes of its own, the tracking event, the engagement level, the key performance indicator. And then we can, these 3 things, the tracking event, engagement level, and key performance indicator, we can aggregate them by any of these dimensions or more. So for example, we can analyze them just by product. And what do we mean by product in terms of Doximity? So we have like a newsfeed is one product, profiles is another product, connections is another product. Then we send out email digests, that is another product. So basically different aspects of the application that we deal with, we call them different products. So we want to see how the user engagement is for each of those products. Or we may want to see how the user engagement is for just platforms. How are the users engaging on iOS versus how are they engaging on Android versus web? Or we may want to see them by users, that how are users individually engaging? Which user is coming onto the platform, how many times a day? Then there is the dates dimension. We may want to aggregate the engagement by year, by month, by quarter. And then we may also want to aggregate them by the specialty, the medical specialty, the neurosurgeon, gynecologist, things like that. So we have these 5 dimensions that we want to analyze this data by. And these dimensions are usually specified by having a conversation with the stakeholders where the initial requirement is coming from. So there could be the senior management, there could be product managers. They may say, we want to track X and we want to be able to view that data using all these different dimensions or bys. So that's the basic input that starts the entire process. One thing that I would like to bring your attention to is that in the DIM users, there is this specialty code. And then we have the specialty table or dimension by itself, and it also has the value code. This is the difference that people sometimes find difficult to understand between 3NF versus dimensional model. So we have a whole different table that has list codes and professional names, and then this data is repeated here. Why not just combine these 2 tables? Why not have a foreign key of this inside this? That's a 3NF thinking, something like this. Why not have specialty and has its foreign key in users, and then users go into user engagement? That way, if we want to combine user engagement with specialty, we can still do that. A different mindset. We can still do that. The problem is that if we want to aggregate or figure out user engagement just by specialty, we have to go through this additional join. If we know, if our requirements are clear that we would want to see metrics by specialty, then let specialty be its own table. It's okay. If we want to view data by user, by specialty, then this and this becomes equivalent, because by user, by specialty, these three will be joined, and by user, by specialty, these three will be joined, which is fine. But if there is a requirement that specialty is its own entity that we want to view our data by or aggregate our data by, then this model makes more sense. So there's a big, there is a big no-no in the dimensional modeling world that two dimensions should not be directly linked. So this immediately breaks the dimensional model practices, and it's not a dimensional model, it's a 3NF transactional model. In dimensional models, dimensions don't talk to dimensions, and fact tables don't talk to other fact tables. Each analysis is its own contained entity. It's possible to reuse dimensions. So for example, there's a fact user engagement. Maybe there is another fact table which shows ad engagement with ads. That fact table can certainly reuse this dimension of users, dimension of dates. Rather, it's encouraged because that way different analyses have the same source of truth. So a single table of users is being reused in different analyses. That's okay. But we don't link dimensions to dimensions, and we don't link fact tables to fact tables. We link fact tables to dimensions and dimensions to fact tables. This is a whole interesting area in itself, the do's, the don'ts, the practices. In the interest of time, I just kept it very simple, and so that we can move on to the next concept also. But what I would like you to remember from this discussion is that dimensional modeling is a data modeling technique for data warehousing. Now, someone might say, oh, data warehousing, that sounds so old. It is. Data warehousing terms initially started being used in the 80s. And initially, the idea was just to take all your production data and dump it onto a separate machine, maybe slightly stronger machine. So that way you have separate data that you can play with for analysis. It was usually the same data. Then that concept emerged into star schemas, and this is called star schema because it kind of looks like a star. There's a center, and then there are emerging rays. I made this diagram pretty so that it actually looks like a star. Some diagrams are not that pretty, but you get the idea. So the star schema idea came in. Again, it's not new, it's from the 80s, that you model data differently for analysis. Then someone might say, okay, maybe in 80s we didn't have a lot of fast machines, so it makes sense. Why do we need it now? We have so much faster machines, and we have the cloud, and we have everything. True. Data warehouse has evolved tremendously over the last 20 years. Even the data warehouse is not even called data warehouse, it's called data lakes. It has been rebranded. Then we have done another things, like we were talking earlier before the talk, that we went from SQL designs to NoSQL designs back to new SQL designs, which actually means that what the original idea was okay, we were kind of messed up. But that's another talk for another time. So the idea of data warehousing still is there. The technology has evolved. Instead of a single machines, now we use multiple cores. Instead of physical machines, now we use the cloud. We have the data volume has increased, so we have all these fun things like Hadoop and MapReduce and Spark. The only thing that has not kept up with all these advancements is the I/O. The data transfer between machines, the data transfer on the network. Somehow, fortunately, unfortunately, it is kind of left behind. So yes, we have machines which are monumentally fast in the 1980s. And we have processing capabilities which are extremely fast, but we still want to reduce the data on the wire because the volume of data has also increased exponentially. And the more we can keep related data together when we are dealing with gigabytes and petabytes and terabytes of data, the faster the overall analysis will be. So the concept is very relevant in today's world also. And as you go into the industry and in jobs, if you're a data scientist, data analyst, maybe a data engineer. So this will be something that will come into play, that this is our production database, and then we want to use it for analysis. What type of ETLs do we need to perform on that? The extract, transform, load. And most of the ETLs are set up to do this. From the relational database, do jobs that can combine relevant data or divide it and then repackage it into these star schemas, from where then further analysts or data scientists or business or commercial users can take it. All right? So this was one concept I wanted to cover. The other one is around, I had an example, sorry about that. That's exactly why I kept this for me. All right, let's see. No, that's work. All right, this is, okay. So this is a dashboard which has been created in Looker. And this dashboard is built on that dimensional model that I talked about. So using user engagement on different levels, this is, the data is kind of made up, but the exact same dashboard exists for our actual data in production. So we are calculating daily active users, that how many active users are coming onto our platform. Then we are calculating weekly active users, the people who have at least one engagement or one active event in the last 7 days. And then we are further breaking it down. People who have only one event in 7 days, 2 events, 3 events, 7 events. So those are the people who are most engaged. Similarly, then monthly active users and quarterly active users. The graphs look exactly the same, as you might imagine that as we are increasing our time frame, the data becomes smoother and smoother. But this is built on top of that dimensional model. This one currently has 2 filters, credentials and top docs, but we can add multiple filters to it, like specialty and application and product, as I talked about. Those are covered in separate graphs, but I wanted to show you this. Going back. All right, the next thing that I wanted to talk about is storytelling with data. So I picked these 2 things because they are kind of on the fringes. We put a lot of emphasis on machine learning and algorithms and data science and statistics and all that good stuff, which is in the middle. But we kind of ignore what comes before that, how the data should be available before that, and what comes after it. So you have done all this amazing analysis and you have some great results to tell people, but then you have no idea how to actually communicate them effectively. And it's not an issue with us in general. The honest truth is we aren't naturally good at storytelling with data. It's the truth. I mean, we shouldn't feel bad about it. An announcement that most of the data and the graphs that I'll be showing in this section is from this book, Storytelling with Data, and that's freely available online. You can look at that for more details. So why aren't we naturally good at storytelling with data? Well, because in our school systems, we had classes of language where we would be learning words and stories and sentences. And then we would have classes on maths where we will solve an equation or put in a formula and get a number, and that's it. We never really learned to merge those 2 skills. So there is maths, numbers, and there is literature. And most of us who are here because we kind of like the maths, the analysis, the analytics part of things. So it's possible that our background in literature or language is not that strong, which is okay. It's a skill that can be learned. It's a skill which is absolutely important, imperative in today's world, as more and more companies are moving towards data-driven decisions. They need to know what the data is telling them. And one thing that we sometimes mistaken about is that we say, okay, we have done our analysis and then we can present a graph and the audience can take it from there, where the audience could be your manager, senior management, anything. That's an incorrect assumption. You are the ones who have gone through all that data and figured out those pearls of wisdom. It is expected that you will tell the audience something, that you will make a recommendation. So unless you know how to read a data, get the story out of it, and present it, all the good work that you have done will kind of not have the same impact that it could have. How do we start with that? So a brief difference between exploratory and explanatory analysis. So exploratory is when you are doing the work yourself. You are trying to figure out different models and trying out different options, figuring out which works best. And once you have something that you want to share, then you move to the explanatory analysis. That's where you engage with the stakeholders and tell them what you have found. It is very, very tempting to show them everything that you have done to get this result. That will show how hard you have worked. That will show how solid your analysis is. That will show all the nights that you have put in this work. It's a good idea in school, absolutely do that. Your teachers should know. But in job, no. Just tell them what you found out. And over time, that builds its own reputation. Sorry, too far away. All right. So who is your audience and what do you want them to know or do? If you're doing a job, it will most probably what do you want them to know. If you're at a fundraiser or you have a marketing job, then probably the do part comes in too. But be very clear about what your audience is, and by the end of what you want to share, what do you want them to know? What specific thing? Or what do you want them to do? What specific item? It's very important that you start with that before beginning with your presentation. And these are some questions that can help with that. There are tons others. There's tons of resources online available. So what's the background information necessary? What biases does the audience have? Who is the main decision maker? What would a successful outcome look like? So think about that and then make up your 3-minute story. We are in the explanatory phase right now. You already done your analysis, you have your results. Create a 3-minute story that if you just have to convey your results to the audience without any presentation, without any graphs, just by words, what would you say in those 3 minutes? It will take you a while to come up with that because 3 minutes is a very short amount of time and you have no graph to point to and no table to show. Once you are done with your 3-minute story, then augment that with graphs and data and tables, because that will keep your message very crisp, because your message is not dependent on any visuals. The visuals are there to support it. Talking about visuals, so what is the best way to show the data that you want to communicate? Just because you have some numbers doesn't mean you have to put them on a graph. Sometimes the most effective, powerful visualization is simple text. Text is a visualization. So here's an example. Example taken from the same book. So children with a traditional stay-at-home mom in 1970, about 41%, and 2012, about 20%. It's a 2014 Pew Research results. So all right. So we have these two, we have this graph, we had some numbers started, okay, let's put it in a graph. This kind of gives a misleading impression that somehow the bigger bar is more important than the smaller bar. It's just the way we are tuned visually, that things that have more volume, we sometimes assume that, okay, that's where most of the attention should go. Whereas probably what this survey results are trying to say is that it's more important what's happening today. Well, it's more like 8 years ago, but in their analysis, that was today. So maybe this 20% is more important than the 41%. 41% was just giving a historical context. So you had a couple of numbers. Instead of putting it in bar chart, if 20 is where the emphasis should be, then let it be 20. Just because, again, I'll repeat myself, just because you have some numbers doesn't mean you have to put them on a graph. If it's a couple of metrics that are extremely important, give them their focus. I'll show an example of that too after this slide. After simple text, the next thing which is used most often are tables. So again, you might say, tables, that's so 1960s. But tables are very easy to interpret, and anyone with any technical expertise or non-technical expertise can read and interpret tables. So use them. In our excitement to use the latest and greatest features, we sometimes ignore how much usability some simple tools bring to us. So don't underestimate simple text, don't underestimate tables. And then of course there are other things, the heat maps, scatter plots, your graphs, stacked bar graphs, other things. They all have their places. But before jumping to that, think that whatever you want to convey with your data, can it be conveyed with a simple text? Can it be conveyed with a table? And then move on to more complex options. Here is an example of dashboard again from Doximity that we use daily. I made it, the numbers are made up. But as you can see, these numbers, that engagement in the last 7 days, from news product, from comms product, from network product, and then this is quarter over quarter increase in engagement, how we are doing as compared to the previous 90 days. So this dashboard, our CEO loves this dashboard. He looks at it daily after waking up. And it gives, like, it's right there, text. And then if they want to look into anything in particular, comms is made up of a number of products by themselves, then you can have these bar charts and bar graphs and everything. But the most important data is right out there in their face, using texts. And then we said there's also a place for more complicated visualizations. This is one. It's called a snaky diagram for obvious reasons. So this one models the lifetime of engagement that is generated by an email. So emails generated of these different categories, I would say. Then how many were delivered, out of the delivered, how many were not opened versus opened, and then how many were not clicked versus clicked. So because this is it's a lifetime kind of a funnel application where all these states interlink with each other. So instead of having too many variables in a graph or too many bar charts, snaky diagram makes sense. Kind of shows you how the data starts and how it ended up, or where it ended up. So it does have its place, but it shouldn't be the first consideration. Talking about a couple of other things. When you are presenting data visually, clutter is your enemy. So understand this. Just like computers have limited processing power and memory, similarly, humans have limited memory and processing brain power also. If you have a blank white page, every single thing that you add on that page is adding to the cognitive load of the reader. So they have limited brain power, they have limited memory. As a designer, as an analyst, try to make it easier for them, that they can understand the most important things without spending the most amount of mental power on it. So what does that mean? So for example, here is one. Same data, 3 different tables. And I think all of you would agree that second and third is much easier to look at and grasp than the first one. This one has heavy cognitive load. Your mind has to decipher, okay, there is some dark colors going on, there's some contrast, there are some lines, and actually the data size is, the width of the data alphabets is smaller than these lines dividing them. So it creates confusion in the mind. It will take you more time in microseconds, milliseconds to understand this as opposed to this, as opposed to this. So keep the cognitive load as minimal as possible. Keep things simple, clean. Going into that a little more detail. So Gestalt Institute of Psychology in early 1900s did some research on how we as humans try to make sense of the world. How do we try to find order among chaos? So they presented a lot of interesting research, and some principles are still very, very effective and true today. So Gestalt principles of visual perception kind of advises us that given data, how does our mind make sense out of it? How does our mind categorize it? So there are some very simple principles, and I'm sure you'll all agree with that. Proximity. Our mind decides that things which are closer to each other in distance are related. So we will look at these points and we'll say, 3 clusters. Proximity. Similarity. Things that are similar in shape, size, or color probably belong together. That's another perception of ours. So we'll say, okay, these 3 cluster, this 3 cluster, and then probably in this cluster, all the things which are blue belong together. That's how our mind visualizes things, understands them. Enclosure. Our mind believes that things which are enclosed together, whether explicitly boundaries or implicit boundaries, probably belong together in some way. And these ones are my favorite, actually. Closure and continuity. Our perception tells us that individual elements are actually part of a group. Our mind processes individual elements in a way that it tries to fit them in a certain group. So for example, you will look at this figure and you'll say, circle. Whereas we don't know what is in those missing spots. It could be anything. But our perception, our mind, tries to fit things in the same molds that it has already seen, or try to form a bigger picture around individual elements. Could be a good thing, could be a bad thing. Trying to fit things into preconceived notions. If you try to do that with people, that's where all the implicit bias comes in. Again, a different topic, a different discussion. But as far as data is concerned, we can use this actually to our advantage. Here's another example. So a graph, two graphs. This is actually gives as much information to us as this one. Sure, it has an enclosure and a background that we talked about here, but our mind perceives things closer are part of a same bigger picture. So this is as good as this. These elements are unnecessary. If we remove these backgrounds from here, we are losing data. If we remove these elements from here, we are actually making things easier for the audience. Another example where our mind tries to fit things, it tries to conform things to what we know about already. So let's say here is these two rectangles, and if I ask you to move the horizontal rectangle down, further down, most of you will imagine that the result would look like this, and hardly anyone would imagine that the result would look like this. So our mind finds continuity. It tries to fit things in the way we have already seen them. It tries to fit individual elements into a bigger picture. And that we can use to our advantage. For example, exercise. Here is a nice looking table, but it has many of the issues that we have talked about in the previous couple of slides. How can we simplify it without losing the data? Suggestions? Sorry, again? Share the difference, that could be one option. But let's say we are keeping the data as is. We are not changing the data, we are changing the visualization or the way it's presented, the visual elements. Area could be a good option. I heard something, go ahead. Remove the border. Let's try to decrease the cognitive load. Every line, every word increases the load on the person. What are the things that we can get rid of without actually losing the data? Go ahead. These lines, okay, I agree with that. We can move these. What else can we do to make it better? Go ahead. The decimals. We are talking about tickets volumes, so probably we are not going to have a ticket with 150.5 as a volume. That's additional things we can get rid of. Go ahead. Excellent. So remember we said that our mind kind of perceives that the things which are taking more volume are more important. So at first glance, people might think, okay, maybe it's something more important is going on here versus here. That could certainly be reduced. Here's a simplified version of that. Many of the things that you guys picked up on correctly. Remove the background lines, remove the border, simplified the numbers, use the standard notation for months, and we actually don't need these plotting stopper points or plotting points because we are already using color to differentiate between the two graphs. If we were to have a black and white picture, then sure, having these different markers would have helped, but they're not adding any additional information here. And then moving the labels next to the data. So reduce the cognitive load on your viewer as much as possible. That will make your data stand out. That will make your point easier to understand and grasp. So that's another example. It's a slightly more involved than the previous one. So basically, what are they showing? It's a Pew Research, new marriage rate by education, less than high school, some college, bachelor's degrees. And then they are showing the data over years. So they are showing the years by colors, and there are all these bar charts. Good data, lots of cognitive load. You look at this data, okay, figure out, okay, there is some things going on here, so probably these are important, the heights, probably colors are important, probably relating the right color to each of these different groups is important. What was the overall point of this again? You get lost in so much information. Probably one example could be this. we are highlighting one of these groups. It could be anything. For example, I picked up this. So bachelor's degree or more. And then we are keeping the other groups, have the years here, and then showing the trends. All the data in this graph, except this all columns, that was not really showing any meaningful data, but it might. In that case, it could also be a line here. But all this data is also present here. But this one is much more easier to understand and grasp because we are working on reducing the cognitive load on the user. All right. So a couple of things that we talked about. Let me just quickly summarize them. We talked about the things that happen before machine learning or data science actually comes into play, the data, and what happens after you have your results, the visualizations. So the data that should be made available for analysis should be in a different model than the relational model or 3NF model because the purpose is different, the volume is different, the intent is different, the audience is different. And then after you have your results, just resist the urges of putting everything in a graph. Maybe they don't belong in a graph. And resist the urge to present everything that you have to the user. Maybe not. Just present the most important things. And then try to reduce the cognitive load on your viewer. Try to take advantage of how we perceive data. And then take it and then use it to your advantage in how you present things. All right, so if you have more, if you're interested and would like to know more about dimensional modeling, Ralph Kimball is the person who originally introduced this concept. His website, Data Warehouse Business Intelligent Resources, have tons of good resources available. Doximity.com about company. If you're interested to know about more what the company does, that's that. If you're interested more about me, then I have a website too. Feel free to ignore this altogether. That's less important. And then the two books that I took a lot of material from, the Data Warehouse Toolkit by Ralph Kimball, and the other one is Storytelling with Data. This one is freely available online. You can download it and have a look. From this one, important sections are already present on this Kimball website. All right, so I should stop here and open for questions.